Hi friends, I am Ranganath Pavgada. Welcome to my video article relating to determination of the exact position of line of division with 100% accuracy in the partition of land of irregular shape without using computer app. Friends, in this video, I will derive some useful formulae which helps you to find the exact position of line of division and the distance of cutting points from the baseline in the partition of land of irregular shape. Let me consider one such case. Suppose you are given a land of shape of open quadrilateral as shown in the blackboard. So in this, the length of the midline, now called the baseline, is known, say, L meter. The two diverging lines are sufficiently longer, and the two included angles between the baseline and the diverging lines are also known, say, theta A and theta B respectively. Now, for a given area A, let us make a partition or subdivision in this land. For this, one had to find the exact position of line of division which cuts the given partition area exactly. To say more clearly, one had to find the perpendicular distance of the position of a line of division. I suppose now you understood what the problem is. Referring to this problem, if we think for a while, we may argue like this. If the given land had been of the shape of a rectangle, then one could easily find the line of division by just dividing the given partition area with the length of the baseline. But in reality, the situation is not so simple. The difficulty lies in the fact that the width of the quadrilateral is not uniform. It increases progressively as we move away from the baseline. Okay, whatever may be the argument, in spite of this difficulty, it is possible to find the position of the line of division, however trickier it may be. If so, how? Let us see. So in this case, two kinds of divisions or partitions are possible. One is vertical division and the other is horizontal division. In this case, we consider only vertical division. Again, in vertical division also, there are two types arises. One is parallel partition and the other is non-parallel partition. So parallel partition is one in which the line of division is parallel to the baseline. If this is not so, then it is a non-parallel partition. In this video, I will consider only parallel partition. I discussed the parallel partition. So coming to the point, suppose CD is the required line of division. Once again, it must be noted that the line of division should be parallel to the baseline. Let the perpendicular distance of line of division from the baseline be x. So in this diagram, ACDB is the boundary of the partition area. Referring to this figure, it may be noted that here the length of the baseline is given. The two included angles theta A and theta B are also known. And of course, the partition area A is given. So all these quantities are known quantities, whereas x is unknown. If one is able to build an equation in x using these quantities, then only it is possible to find x. Then only it is possible to express x in terms of these quantities. If so, then how to build an equation in x? This is a little bit brain-teasing, thought-provoking situation. Okay, you need not worry. To unlock this problem, you just drop two perpendiculars, one AE and the other BG, respectively, on the line CD. This is clear. The two perpendiculars will divide the partition area into two right angles and a central rectangle. So in this figure, AE is equal to x, BG is also equal to x, because CD is parallel to the AB. Again, AB is L, EB is also equal to L. This is because AE and BG are not only perpendiculars, but they themselves are parallel to one another. So next, in the upper right hand triangle AEC, let us call the acute angle CAE as theta 1. Let CE be H1, which is opposite side. And here in the lower right angle triangle, let us call the acute angle GBD as theta 2. The opposite side GDB H2. Having designated all these quantities, the next is to find an equation in X. I suppose that to find an equation in X, it is convenient and it is better to find H1 and H2 first. So, the first step is to find H1 and H2. So now, in upper right angle triangle AEC, theta 1 is equal to, since AE is perpendicular, theta A minus 90 degree. So now, you consider a trigonometric ratio tan theta 1. So this is opposite side H1 divided by the adjacent side X. On cross multiplying it, we get H1 is equal to X tan theta 1. So call this equation as 1. Similarly, next consider the lower right angle triangle BGD. So in this, since BG is perpendicular, theta 2 can be written as theta B minus 90 degree. So here also consider the trigonometric ratio tan theta 2. This is H2 by X. On cross multiplying it, this gives H2 is equal to X tan theta 2. Call this equation 2. So the two equations gives the opposite sides. If X is known in terms of theta 1 and theta 2. So in the diagram it is clear, the line of division, that is the length of the line of division, will be a sum of H1 plus L plus H2. So call this equation as 3. So the next step is an important step, that is to find an equation in X. So the second step, to find equation in X. So now, referring to the diagram, from geometry, it is clear that the partition area A is equal to sum of the area of triangle AEC plus area of triangle BGD plus area of rectangle, that is AEBG. So AB is equal to area of the triangle, we know half into base into height is half into X into H1. Again for the lower triangle, half into base into height and half into H into H2 plus area of the rectangle, length into breadth, that is LX. Next, from equation 1 and 2, substitute for H1 and H2, that is X tan theta 1 plus half into X into tan theta 2 plus LX. So in this, X into X square, X into X square. So X square is a common factor. So I am removing this common factor. one can write the equation is equal to A is equal to half into tan theta 1 and tan theta 2 plus into x square plus Lx. So here theta 1, theta 2 are fixed and known. Hence tan theta 1, tan theta become finite. Hence the factor of x square will reduce us to a constant. So put half into tan theta 1 plus tan theta 2 is equal to k, a constant. On substituting this constant in the above equation, the equation becomes A is equal to kx square plus Lx. Now transpose A to the right side and rewriting, one get the equation kx square plus Lx minus A is equal to 0. Now divide the entire equation throughout by k. So the above equation becomes x square plus L by k into x minus A by k is equal to 0. This is one of the familiar equation which you may guess. This is nothing but the quadratic equation in x. This is of the form ax square plus bx minus c is equal to 0, where a is equal to 1, b is equal to L by k, and c is equal to a by k. So thus we are able to build an equation in x in terms of L, a and k depends on the angles theta 1 and theta 2, which in turn depends on theta a and theta b. So the next step is to find, that is, I suppose the third step, that is to solve for x. So x is perpendicular distance. So again, it is a quadratic equation, and from Sridhar's formula, one can directly write the solution for x as x is equal to minus b plus or minus square root of b square plus 4c in this case by 2. So obviously, the x had two solutions. The only possible and acceptable solution for x in this case is x is equal to minus b plus square root of b square plus 4c by 2. Call this equation or expression as 4. So this is an important expression, and this gives the exact position of line of division or perpendicular distance of the line of division from the baseline. By substituting L by k in place of b and a by k in place of c, one can directly calculate x. The problem is not yet completed. Still, we are required to find the position of the cutting points C and D, or the distance of the cutting points C and D from A and B respectively. So the next step is, I suppose it is fourth step, to find distances of cutting points C and D. So we know in a rectangular triangle, In the upper right angle triangle, AC is the hypotenuse. From applying the Pythagoras theorem to this, it says the square on the hypotenuse is equal to sum of the square from the other two sides. Since we need AC, put a root sign over it. So this is x squared. Substitute for h1 and hence h1 square. So this becomes x squared tan square theta 1. So AC becomes square root of x will be common factor, remove it, 1 plus tan square theta 1. So that is equal to x square into, here 1 plus tan square theta 1 is a trigonometric identity and it is equal to secant square theta 1. So thus AC will be x secant theta 1 or AC is equal to x. Since secant theta is the reciprocal of the cos theta, one can write AC also equal to the x into 1 over cos theta 1 or x by cos theta 1. So to find the distance of the first cutting point C from A, you can use either of these formulae. You call this an equation, say 5. On the similar line of argument, one can write directly for the distance of cutting points in the lower triangle, that is AD is equal to x secant theta 2 or AD is equal to x by cos theta 2, call this in equation 6. So is it clear? All these formula 1 to 6 will give the lengths of different sides of the entire boundary of the partition area. So in particular, the formula 4 will give you the exact position of the line of division in the partition of land of irregular shape such as quadrilateral. So in the next video, I will discuss using this formula the numerical calculation taking a specific example. Thank you. If there are any comments, likes, even dislikes, they are cordially invited. Please subscribe it, share it. Thank you once again for watching my video.